Welcome back to graphing linear equations. In the first learning target, we looked at how to calculate slope using the slope formula and how to find slope on a graph. Now we're looking at slope-intercept form of a linear equation. This is where the equation has been solved for y. So there are other forms, such as standard form, ax plus by equals c. This is called standard form. And if we want to graph using slope-intercept form, or if we want to use slope-intercept form to help us with solving a system of equations or doing something, we would want to solve for y to get it by itself. So I'll do that real quick over here. To get y by itself, the very first thing we would do would be to undo addition and subtraction, so we would subtract the ax. Then we would want to undo multiplication and division by multiplying by the reciprocal. But we'd have to multiply everything by it. So we get y equals negative ax over b plus c over b. Now, this division will give us a number here. This division will give us a number here. The number in front of x, the coefficient on x, we label as m. And the constant that follows we label as b. So slope-intercept form, most students can say y equals mx plus b if you've seen it before. But what does it mean? Well, m is the slope of the line. By the way, this only works if it's a linear equation. If it's a quadratic or some other type of function, then this will not work. And b is the y-intercept, or where the graph will cross the y-axis. 0 for the x-coordinate, comma b, the height of the graph on the y-axis. So let's take a look at graphing some of these using slope-intercept form. If they're already in slope-intercept form, we can just state the slope in y-intercept and graph. If they are in standard form or some other form, we may need to solve for y first. Here are our examples. In this one, the coefficient on x, y is by itself, so it is in slope-intercept form. The coefficient on x is 3/5, so the slope is 3/5, a rise of 3, a run of 5. The y-intercept, or what comes after the constant, is negative 2. So I've now stated what the slope and the y-intercept are. To graph this, I will start at the y-intercept, 0, negative 2, as my point. And I will follow the slope of up 3, right 5. 1, 2, 3, 1, 2, 3, 4, 5. I could also reverse that slope by going down and left. Down 3 and left 1, 2, 3, 4, 5. Use a ruler or straight edge to connect my points, and I have my line graphed. The next example is also in slope-intercept form. Y is by itself, there's a coefficient on x, and then there's a constant afterwards. Here, the slope is negative 3, which I can write as negative 3 over 1, which means that I would go down 3 and right 1, or I could go up 3 and left 1 if I want to do this as 3 over negative 1. I could go up 3 and left 1, and it would give me the same thing. The y-intercept is 4, or 0, 4. So I start at my y-intercept of 1, 2, 3, 4 on the y-axis, and I go down 1, 2, 3, and right 1. Down 3, right 1. Down 3, right 1, down 3, right 1. Or I reverse the slope and go up 3 and left 1. And all of my points fall on one line. In this last example, it is not in slope-intercept form, so we will have to solve to get y by itself. I begin by subtracting 4x to move it to the other side. This gives me 3y equals negative 4x plus 6. To get y by itself, I divide every single term on both sides of the equation by 3. This gives me y equals negative 4/3 x plus 2. So this will be the equation that we're going to graph. From this equation, our slope is negative 4/3, and our y-intercept is 2. So we start at a y-intercept of 0, 2 on the y-axis, and the slope of negative 4/3 means that we go down 1, 2, 3, 4, and right 1, 2, 3, down 1, 2, 3, 4, and right 1, 2, 3, or we could reverse the slope going up 4. If I make this 4 over negative 3, I could go up 4, 1, 2, 3, 4, and left 1, 2, 3, and I get all of my points on one line. Please pause the video and try the next two problems. Welcome back. For triad A, you should have had a slope of negative 4/5 or 4 over negative 5. They are the same slope, it's just a difference in how we plot them. The y-intercept is 2 or 0, 2. Starting at 0, 2, we can go down 1, 2, 3, 4 and right 1, 2, 3, 4, 5. Or we could go up 1, 2, 3, 4 and left 1, 2, 3, 4, 5. If this is the graph that you have, then you did it correctly. For the next one, in solving for y, you should have subtracted 9x from both sides. Then you should have divided every term by negative 8. Negative 9 over negative 8 gives us positive 9/8. 72 divided by negative 8 is negative 9. So this graph will start at negative 9. Now, we could rescale this axis to go by 2's if we need to. In fact, I think I might do that. The other thing is, since this goes down to 8 already, I could just add 1 tick mark since we're only 1 off. I'm going to do that, but I could rescale to make this 2, 4, 6, 8, 10, and this negative 2, negative 4, negative 6, negative 8, negative 10. If I need to rescale, then I can rescale the graph. Now, starting at negative 9, I'm supposed to go up 9 and right 8. I can't go down on this particular graph, so there's only 2 points that I'm able to plot on this graph paper. Our slope we label as 9/8, our y-intercept as negative 9. This concludes the clip on how to graph using slope-intercept form.